This is Richmond. This is my YouTube channel, and it's for math and science only. I want to make math and science very easy here. So, if you want to learn science and math, please, this is a very good channel for you. All that you need to do is just subscribe to my channel by hitting on the red subscription button there, and then you'll be part of the group. And you can also click on the notification button up there, and then you'll be notified anytime.
Okay, so this is Richmond, and today we are talking about how to find the limiting value of a function. So, talking about limits of functions. Okay, so I will define the limit of function. The limit of a function f of x, when I talk about limit of function f of x as s approaches the value a, we write it this way. The limit, okay, as x approaches value a. So this is how we write it. So the limit of function, and this is the function f of x as x approaches a. This is actually how we write this. We define the limit. Okay, so how can we even obtain the limiting value of this expression? Okay, to obtain the limit, we replace x by a in the function. So if we want to find the limiting value here, or to find the limit here, what we need to do is that we replace the x here by a. So our limit of the function f of x as x approaches a is now equal to f of a. Okay, so and this one become our limiting value. So in dealing with limits, all that we need to do are always x will approach a value. X will approach a value. So all that we need to do that we just replace x by the value that is here. So now we have x is approaching a. So to solve it or find a limiting value, we just replace the x by a. So let's take examples and see how this question could be solved. Okay, so let's say that find the limiting value of the following. We have limit x approaches 3 x plus 4. To solve this question, all that you need to do is that the definition of the limit states that the limit of function f of x as x approaches a value a is written as this. So now to obtain the limiting value, we replace x by a, and this is our answer. So this place, to find the limiting value here, we replace the x here by the value here, which is 3. So our answer will now become 3 plus 4, which is equal 7. Okay, so let's take another example and see how this could be solved. So this will be our, this is example 2, and it's a limit as x approaches -2, like this. And then this is what we have, 2x cube plus 3x square plus 5x then plus 6, like this. Okay, so all that we need to do here is replace the x, all the x that we have in this expression, by -2. So let's continue from this place. It's going to be the limit as x approaches -2 will now be equal to this. So 2, and then our x cube is replaced by -2, and then we keep it plus 3, and then our x here is negative 2. We square it, plus 5, and then our x minus 2 here, like this, and then plus 6 finally. So let's try and expand this expression and see the result I will get. By expanding this expression, we're having negative 2 raised to power 3 will give us negative 8 times 2 will give us minus 16 here. Negative 2 square will give us positive 4 times 3 will give us plus 12. Plus 12 here. And then 5 times minus 2 will give us minus 10. And then plus the 6 there. And finally, we will get minus 8 after performing all the operation. So this is basically how we find the limiting value of an expression. Okay, so let's try and then take another example and then see. Limit of a rational function. How do we find limit of a rational function? And even what is a rational function? Okay, so we are talking about limits of a rational function. Okay. Limit of a rational function. A function f of x, so I'm defining a rational function. A function f of x is said to be rational if it can be expressed as quotient of two polynomials in x. So if I can have f of x to be equal to g of x over h of x, because I've expressed this in the form of a fraction, or I've expressed this as quotient of two polynomials, that g of x over h of x. And these conditions hold for which h of x should never be equal to 0. Okay? So when we have an expression like this, we say it's a rational function. So how can we find the limiting values of the rational function? Okay? So we take some examples, or there are some conditions here that we need to know in order to solve this rational function or find the limit of rational functions. First condition is this. Okay, let me write the condition here. First condition is this. Any number except 0 divided by infinitely large number is 0. If you have any number other than 0 divided by infinitely large number is equal to 0. So what I want to say is that if I have a number, let's say 4 over infinity, the answer should be 0. So every number divided by infinity or infinitely large number, we have 0. So that's the first condition. So with this condition, if I have the limit as n approaches infinity, 4 over n, this will give us the result of 4 over infinity. And we know that because n approaches infinity, you have to replace the n by infinity, and this one will give us 0. That's the first condition. And then the second condition says that any number except 0 divided by 0 is infinity. Any number except 0 divided by 0 is infinity. So if I have a number, let's say that's condition 2 here. Okay, that's condition 2 here. If I have any number at all except 0 and it's divided by 0, you get infinity. So let's say take this example. So we have 4 over 0, we get infinity. 5 over 0 is equal to infinity. That is the condition. Any number except 0 divided by 0, our result becomes infinity. So in a limit, if you have something like the limit as x approaches 0 for x. So definitely this one is going to be 4, and you replace our x by 0, so we're going to get infinity like this. That's the condition. Let's move on to the last condition, and then we start solving some questions. 0 divided by any number except 0 is 0. So if I have 0 divided by any number, 0 divided by any number at all, you get 0. So 0 over 2 is equal to 0. 0 over 10 is equal to 0. So this is the second condition. So when I have something like that, a limit, okay, as x approaches, let's 7 here, 0 on x like this, definitely what I'm going to get is 0 over 7, and the answer become 0. Okay, so basically this is the conditions that we need to know in order to tackle any question on this, to be able to solve it with an ease. Okay, so we are continuing. We are taking an example here to see how we can solve this type of questions. And then the first example is you have a limit. So let's take example 1 here. And then this is how you're going to do it. So example 1 here, and then the question is limit x approaches 2, and then we have 2x minus 2 over x minus 1 like this. Okay, so all that we need to do is that we simply replace x by 2. So I'm going to get 2 here and replace the x here by the 2 here, because x approaches 2 minus 2 all over 2 minus 1. So we are going to get 2 times 2 give us 4 minus 2 over 1, which will give us 2 finally. So this is how we deal with a question like this. Let's take the next example on this rational function. So our example 2 is also like this. The limit as x approaches 1, and then we have this s squared plus 1 all over 2 s cube minus 1 like this. Okay, and then all that we're going to do is that x approaches 1, so let's substitute 1 into this particular, wherever we see x, we substitute it by 1, or we replace x by 1. So you're going to get 1 square, because s is equal approaches 1 here, plus 1 all over, we have 2 here, and then here will be 1 cube minus 1. So have here 1 square give us 1 plus 1 give us 2 here, simple over 2 minus 1 will give us 1, and our answer becomes 2. Very simple. Okay, so some of the questions are in such a way that if you have the question is given, and then after you replacing the value of x into the expression, you get 0. So if you have a question like that, all that you need to do is that you have to simplify the expression before replacing the value that x approaching. Okay, so let's take an example here, and then let's try to deal with such problem. So when you meet one, you know how to do it. So a question like this, the limit x approaches 2 here, and I have x squared minus 4 over x minus 2. Let's look at something here. When I replace x by 2, what will happen? I'll get 2 squared minus 4 all over 2 minus 2. So I'm getting 4 minus 4 over 2 minus 2, which will give me 0 over 0, give me 0. So you get 0, and this is not the right answer. So when you just substitute the 2 into the expression or the rational equation or the rational function here, and then you get 0 straight away, all that you need to do is that you need to get back and then simplify your expression. Okay, how do you simplify this expression? We can say here limit of x approaches 2, and then we know that this is x squared and this is 4, and 4 could be 2 squared, so we can say x squared minus 2 squared over x minus 2, and this one become a difference of 2 squared, and then we can put them like this: x plus 2 and then x minus 2, difference of 2 squared. If you expand this one, you're going to get this as your answer. Okay, all over x minus 2, and this, you can see that x minus 2 can deal with x minus 2 here, so x minus 2 cancel x minus 2, and now our expression now become the limit as x approaching 2, we have just x plus 2 like this. Okay, so what do we do now? We can just substitute x to be equal to 2 here, and we are getting 2 plus 2 will give us 4. Very simple like that. Okay, so let's take another example like that and see how we can also solve it, so that after this example I know that we can solve any other questions. So let's take this example, which is the limit x is approaching 3 here. Okay, and then we have x minus 3 over x squared minus 5x plus 6 like this. When you substitute 3 into this expression or function, rational function, what I'm going to get is this. You're going to get 3 minus 3 over 3 square minus 5 3 and then plus 6. Let's try and break it down. We get 3 minus 2 give us 0 here, and you know that this 3 square will give us 9 minus 15 and then plus 6, and you know that 6 plus now give 15 minus 15 gives 0, so we're going to get 0 over 0 will give us 0. And I said that when you meet a situation like that, all that you need to do is that try to break the function down, break it down simple. So let's break this function down and see what we get. So we're having a limit x approaching 3 like this, and then we have 3x minus 3 all over. So here it's a quadratic equation here, or quadratic expression here. So what you need to do is that you write our x squared, and then with our 5 minus 5x and then the 6, we need to just two numbers here. When we add them, we get minus 5. When we multiply them, we get positive 6. So this will become what we are dealing with here. So what are the two numbers? When you add, we get minus 5. So we get minus 2x, okay, minus 3x. When I put minus 3, minus 2, and then minus 3, I get minus 5 here. So we just use this one to replace the minus 5 here. And then after the 6, we bring it here. Because if I multiply minus 2 and minus 3, I get this positive 6 here. Okay, so this is what we need to do here. And then after doing this, what do? We just try to factorize them out. So we're going to get something like this. The limit is my x approaches 3 here, and then we have our x minus 3 here, and then x squared minus 2x. We can factorize x out, so x can come out and left with x here minus 2. So minus, and then here we can factorize 3 out. Okay, we can factorize 3 out here, and 3 out, 11 3 here, 11x here, so write x here, minus 3 into 6 divided by 3 will give us 2, like this. Okay, so we can now simplify like this. Our limit as this x approaches 3 will be x minus 3 all over x here, and then x. So we have x minus 2 here, x minus 2 here. We just pick one, x minus 2, and then x minus 3 here, put them together, x minus 3, like this. In a simple way, you can see that x minus 3 is here and x minus 3, they can cancel out. And then we now have simply our limit as x approaches 3 now becomes so now it becomes this cancel this, so level 1 here over x minus 2. Okay, so what is the limiting value? Now we replace x by 3, so you're going to get 1 over 3 minus 2, which will give us 1 over 1, which is 1 as the answer. So this is how we deal with such